Hi everyone, my name is Leela Manikrishna and my roll number is 5I0. Today I am going to explain the seminar from the subject DLD, Digital Logic and Design, and I took the topic subtraction using r-1's complement method. Generally we use r-1's complement method to find the subtraction. We use complement only to find subtraction. For suppose if we take subtraction, in the subtraction we subtract from two numbers. So the first number, if I take ABC, it is termed as minute. And the second number, if I take PQR, it is called subtrahend. So the number which is to be subtracted is called as subtrahend, and the first number is termed as minute, and the result produced is called as difference. So the first number is called minute, and the number which is to be subtracted is called subtrahend, and the third number is called difference. Now the basic formula we should remember while performing the subtraction is the two numbers must have equal number of digits. The two numbers which are involved in the subtraction, that is the first number minute and the subtrahend, should have equal number of digits. So this is the basic point. We should make equal the digits and then we should go on the further procedure. And in this, the first number minute is termed as capital M, and the second number subtrahend is termed as capital N. So these are the basic terminology about subtraction, and subtraction using r-1's complement is a three-step procedure. Now I am going to explain them clearly. Now procedure. It is a three-step procedure. The first step is add minute, that is the first number, to the r-1's complement of the subtrahend. So the first step is adding the minute, that is the first number, to the r-1's complement of the subtrahend. Whatever the r may be, we should find r-1's complement of the subtrahend first, and then we should add it to the minute. Now I will explain how to find r-1's complement of the subtrahend. If I take for example 77 to the base 10, here small r denotes radix, that is 10, and small n is the number of digits present in the given number. In 77 we have 2 digits, so small n is equal to 2, and capital N is the number itself, that is 77. So we have a formula to find r-1's complement of any number. So r-1's complement it is given by small r power small n minus capital N minus 1. So we should remember this formula. Now I am applying this formula in the given number. So 9's complement is equal to small r is 10. 10 square minus 77 minus 1. So this is 100 minus 78, that is 22. So in this way we can find r-1's complement of the subtrahend, and after finding it we should add it to the minute. Now I am going to explain the second step. So basically second and third steps are based on the sign or magnitude of capital M and capital N. Now mathematically, in the first step, capital M minus capital N equal to, this minus n is the r-1's complement, so capital M plus r power n minus capital N minus 1. So remember this one. So it can also be treated as this one. So this is the first step. Next, second step, if capital M is greater than capital N. That is, if minute is greater than suprahend, then sum will produce an end carry. Sum will produce an end carry. To get the final result, we should discard the sum and we should add a digit 1. So to get the result, discard the end carry and add digit 1. So then it will become the final result. So we are adding digit 1 because we are using this based on r-1's complement. Suppose if we perform the same subtraction using r's complement, then it is not necessary to add digit 1. As we are using r-1s, we should add the digit 1. This is when capital M is greater than capital M. So the sum will produce an end carry. So we should discard the end carry and to the sum we should add plus 1. That will become the final answer. Now the third step is, if capital M is less than capital N, the sum will not produce an end carry. The sum will not produce end carry. And the sum produced is equal to the r-1's complement of capital N minus capital M. Sum produced is r-1's complement of capital N minus capital M. So to find the final result, we should again perform r-1's complement to the sum produced and we should place a negative sign before it to get final result. Do r-1's complement to the sum and place a negative sign before it. So this is the third step. First step is adding the minute to the r-1's complement of the suprahend. It is denoted mathematically by this. Next, the second step is, if capital M is greater than capital N, the sum will produce an end carry. So end carry will be produced. Now to get the result, we should discard the end carry and add digit 1. We are adding because we are using r-1's complement method. Third step, if capital M is less than capital N, the sum will not produce an end carry. And the sum produced is equal to the r-1's complement of capital N minus capital M. But we need the final result. To get the final result, we should again do r-1's complement to the sum and place a negative sign. So this is a 3-step procedure. Now I am going to explain problems. So the given question is, subtract the following decimal numbers using 9's complement method. So decimal number radix is 10 and it will become r-1's complement, that is 9's complement. And here we have two questions. One is 3570 minus 2100, where M is greater than N. So the minute is greater than suprahend. And in the second question, 753 minus 864, where M is less than capital N. So there are two cases. Now we will do the first problem. First one is 3570 minus 2100. So the basic one is number of digits should be equal in both the numbers. So here there are 4 digits and here also 4 digits. Now proceeding the first step, 9's complement of suprahend. Here suprahend is 2100. 9's complement of 2100. Here radix r is 10 and number of digits is 4. Capital N is the number itself, 2100. So 9's complement. Already I told the problem formula, that is r power n minus capital N minus 1. So r is 10. 10 power 4 minus n is 2100 minus 1. So 10 power 4 is minus 2101. So I am doing here 2101. So subtracting 7, 8, 9, 9. So we got 7899. This is the r minus 1's complement of the subtrahend. Now we should add this to the minute. So adding, addition to minute. So the minute is 3570 and this one 7899. 9, 16, 14, 11. So here end carry is produced. So if end carry is produced, we should discard the end carry. To the given sum, we should add plus digit 1. So result equal to 1469 plus 1 equal to 1470. So this is the final result. So 3570 minus 2100 equal to 1470. So this is the first problem. So first I did the 9th complement of subtrahend. So by doing the 9th complement we got 7899. Now adding this to the minute. So we got an end carry. So we should discard it and add digit 1. So by adding digit 1 we got the final result. Now I'll explain second problem. So the given second problem is 753 minus 864. So here subtrahend is 864. First step is 9th complement of subtrahend, that is 864. Similarly in the previous way, radix r is 10. Number of digits present in it is 3 and capital N is the number itself, 864. Now 9th complement, r power n minus capital N minus 1. So r is 10, 10 power small n is 3 minus capital N is 864 minus 1. So this is 1000 minus 865. 865. 1, 3, 5. So we got 135. This is the 9th complement of subtrahend, that is 864. Now adding to minute. Addition to minute. So the minute is 753 plus 135. 8. In this case end carry is not produced. So again we should find 9th complement of the sum. 9th complement of eight. So r equal to 10, small n equal to 3, number of digits, capital N is the number itself. So 9th complement, already we know the formula, r power n minus capital N minus 1. So r is 10, 10 power 3 minus capital N is 8 minus 1. So this is 1000 minus 889. 1889. 10. 111. So we got 111, and we should remember to place negative sign before it. So the final result equal to minus 111. So in this problem I did 9th complement of subtrahend 864. I got this using this formula. I got this 9th complement as 135. Now next adding it to the minute. By adding I got triplet. As no end carry is produced, Again I did 9's complement to 888 and I got the 111, and we should place negative sign before it. So in this way we can perform not only for 9's complement, or for binary numbers also we can perform. Thank you, hope this helps you.